is this one, enhancing homelab security and leveraging confidential computing and DRTM for intranet, not internet, intranet-only workloads. So I don't know if Daniel is here because I invited Daniel. I wanted to invite Andrew, but he said he's not available, but he's available. So that's good. Like we should add Andrew at the end. We have Marek.
To be very clear, that's because everyone else has wandered off somewhere and didn't want to stay in the pub. So
yeah, I know. Yeah, obviously, but you can drink with us. Like that's completely fine, Andrew. Like if you have something, then it's welcome here. So we have Marek. I don't know if we have Michał Kowalczyk from Invisible Team Club.
I'm here.
Hi, Michał. I guess you are also in Zurich, yeah?
Yep.
Yeah. So we have two people from Zurich today, like in Zurich, or maybe not from Zurich. But, we have Patrick. Patrick from Hunix. Patrick, are you there? Can you speak up? Okay, I don't know. Maybe Patrick got a mic problem. So I mostly invited Patrick because his website on Kik Secure, which I will link in a second, is part of like a foundation for this talk. That's me, and we have Daniel. Daniel, I see that Daniel just joined. Hi, Daniel.
Hello.
Okay, great. So let's try to do this in a round. Like I would say like this. The format I would like to have is like we will try to gather the feedback from those panelists on the topic by 10:30 or Central Europe time. So like next 25 minutes, and we will go in a round starting from Marek. So you can express your kind of opinions or vision or challenges that you see with using the confidential computing technologies in this kind of use case, like intranet-only workloads. So the idea is to use that in a home lab environment. So I have my home lab, and how I can improve. Let's say this home lab is also like open source firmware based, but I would like to use in this home lab. Let's say this could be a workstation, so it could be a CubesOS based system. How I can leverage confidential computing features to improve security of my home lab. So let's say even I can host intranet services, but this is not for, it's not perspective of cloud provider. It's not something like I expose to the world and want to have access to the services from external world. It's just for me, for my family, for my internal ecosystem. And how we can leverage that. So we talk about memory encryption. So, but there was also this attack, like kind of consideration about attack that someone entering to my home and like a kind of, steal the device or maybe even try to do cold boot attack. So like this is, let's say this is in scope. But that's it. That's it. Other stuff is described in the talk description abstract, and maybe we can start with Marek. Please tell me what do you think, and then after this 10:30, we can join discussion with others and try to answer. Maybe there will be some questions. Then we will try to answer those questions. So Marek, please start. Okay, is it that just me not hearing Marek? Does anyone hear me?
Probably not only Leo, because I can hear you, but I cannot hear the speaker.
Mark, you're muted, so maybe this is again.
Also, in regards to what I see on the screen, there's a reason why I wrote this.
Oh yeah, we hear you.
Test is working.
What? It muted itself. Ooh, what the
you pressed the M key when you had the focus in the wrong point. That was what was.
Probably. Probably.
Yeah.
Okay, whatever. So I think this all depends on the threat model and specifically whether the physical access is in your you consider a threat of physical access or not. Because if you do, you have several issues that can be somehow that cannot. So DRTM can help you with various like protecting boot files, protecting firmware, or at least checking if you are still running the right one. But there are several points where DRTM will not help you. Like if, for example, somehow replace your RAM with a modified one, you've seen the bad RAM thing.
Excuse
then
me.
DRTM will not help
Is it
you
only
much.
me, or am I just
Yeah.
hearing you very distorted?
Same.
Yeah, same a little bit.
Same
And it
here.
was also like that earlier. Although I may be confusing with someone else.
Okay, let me.
It is
one
understandable,
thing.
however, yeah, it's kind of still difficult to hear you.
Mhm. Okay, is it better now? Test.
No, that's worse if
Still the
anything.
same.
Oh no. I guess I can close some more things.
You're not
What
going to
about
tell me
now?
this is interrupt latency latency problems, are you?
Yeah, certainly.
I guess maybe this is
Yeah,
like a video companion or something, like audio over Cube's RPC or something, or not?
Oh, something you
I
probably
guess
ought to know.
it's.
So there's a patch series to Zen from Ford, who are completely brand new to the mailing list. The reasons why will become apparent at some point, but the task they're currently working on is getting AMD AVIC working. So you might have accelerated interrupts working properly sometime sooner rather than whenever I next have some free time.
Yeah, okay.
Yeah, so maybe we can
So-
like jump to Michał, and Marek, maybe you can like try to look if you can solve that.
Yeah, I can probably switch devices. It should be quite, yeah. But so I guess it's Michał.
Okay. So
Wait, so as someone who's in my experience, I'll say that the biggest issues I've had with cubes and video stuff is actually when I've been using a wireless connection. Wired has generally worked fine.
Yeah, Demi, let's give Marek a chance to fix that, and let's listen to what Michał have to say about the topic that we're trying to drive here.
So I can continue what I think Marek was saying about DRAM. So one of the problems with the current solutions is that in both the server SGX and TDX, and it's the same with AMD SEV. The problem is that they don't have Merkle tree with the encryption, so like the threat model has to be quite limited. For example, if you insert a malicious DRAM, then it can be exploited. So it's expensive to do that, but I'm not sure what's the. Does anyone know if that was already done? I think not.
Funny you should ask this question. 2 days ago, there was a new attack published.
Yeah,
It's called Bad
yeah.
RAM.
But that
so-
exploits, I think that exploits the missing checks on the AMD, which are present in MCheck on Intel, right? Because Intel has this procedure, I think in one of ACMs, which validates the DRAM configurations when setting up SGX.
I think it is the TXT BIOS ACM. It does the alias checks.
Yeah.
During or right after memory init. I think that's the one. But there's also the MCheck, whatever it is, and I'm not sure about this one.
Yeah, MCheck is not
but-
public. Like it's not known how exactly it works, but
Yeah,
I think they listed that it also checks the aliasing.
yeah, it could be. But I have no idea what it is, but I recall from the SGX initialization flow that the MCheck has to approve the peer MRR.
Yeah, MCheck is a huge bunch of things that include things like are PMRRs set up uniformly across the system. My unofficial understanding is that it's a dumping ground of a lot of security related stuff. And the name MCheck is legacy and not completely representative of what it is today.
Mm-hmm. So I think if I understand correctly, with this new bug from 2 days ago, it was missing checks on AMD, and Intel didn't have that problem. Yeah.
Well, it's a couple of.
Oh, you're muted.
Now Andrew gets auto-muted.
Yes.
Okay, that was not me because I had nothing touching the.
Yeah.
Okay.
Yeah, that instance auto muting. Like I think this is like a problem with update. But anyway, like Andrew, please.
Security feature.
Yeah. So where had I got to?
MCheck ACM on Intel may help, and the questions from Michał is like, does bad RAM is only a problem of AMD or also potentially Intel?
Bad RAM is not an AMD specific problem. It is general to everyone. It's just that AMD came crashing down quite easily. Part of the problem is the bad RAM found that if you can physically remove the DIMM, you can reprogram the SPD data, and that's literally required by the spec. It's also required by the spec that you can that the data is immutable when it's powered on. And one of the problems that caused bad RAM to be a lot worse than otherwise would be is that there's a whole bunch of chips that didn't even have the SPD write protect enabled, which means that you could pull the attack off straight through SSH. You didn't even need to go and unplug the DIMMs, put them into the magic reprogrammer and put them back.
I see. But on top of that, there's still that design problem that in both new SGX and AMD SEV, you don't have the Merkle tree. So if you were able to program your own DRAM, I'm not sure how viable is this, or snoop on the DRAM bus, then you can replay pages to older versions and basically corrupt memory, because the signature is per page.
So
Yeah, you can essentially sit on SM bus, like on many boards. Like the DIMM slots are not the only place that SM bus is exposed. Like there are often some SM bus headers for some external stuff like dash or sensors and many other things.
I think the answer is, if I had to guess, I'd say that this is probably simply because the threat model for this simply has these as out of scope. It's designed.
Yeah, but it
it's designed.
assumes it assumes that it's very expensive to do that. But
It's not just that; it's also that in a lot of the cases where it's deployed, you legitimately don't care about these attacks because.
Yeah, so okay, but because like we're going down the whole like okay how it is not practical, how it is.
Yeah,
not
but also this is getting off topic.
Yeah. It's like we should like focus more on how if confidential computing related technologies that are included in modern CPUs can improve the security of like a normal human being which got its own couple devices in home and using intranet for some services. That's our goal and that's our focus.
So going back one quickly just to finish off that topic.
Can you hear me?
Yes,
Can
we
you hear
can.
me now? Does it now
Yes.
work?
Yes,
Wow.
we hear you. We also hear Patrick.
Nice.
Okay.
We also hear you as well.
So yeah, for home user, I think this firmware security stuff, I'm not sure I have an unpopular opinion here, but I think it's not so likely that somebody is going to try to hack the firmware of a home user. It would be much easier to use some low-level technology, like my favorites ideas are miniature cameras or laser microphones. It's much simpler. You don't need to know the motherboard firmware is motherboard specific. It's much easier than hacking the firmware. Like another side channel.
You can also obtain the password through Wi-Fi. 3D scanning.
Yeah, or installed keylogger in your the cable for your keyboard, right?
Yep.
So yeah, and
Yeah.
no DRTM will detect any of those. So that's the problem with the threat model where physical attacks are in scope.
Yeah, exactly. So-called hardware implants.
Yeah, but that's still pointing mistakes and still pointing problems. So it's like the answer is
no.
There is no way to improve.
No, there is a solution, right? And so you keep looking for a software solution. There's a solution. It's called Steel. Grade 8 steel, not from China, from Germany. You know, there is a well-documented 500-year history of how to solve this problem.
Build a bunker or whatever.
Can we just leave these?
Wait! I missed something.
Can we get back on topic and like pretend for a moment that physical attacks are out of scope, and that way we can have an interesting discussion. Because, like, let's just pretend that they're out of scope, and then.
Generally, I think
confidential computing where.
For most cases, Rich is right here. So focus on physical attacks with physical measures. Like you can have some hardened case for your system. You can have some tamper detection or something like that on the physical level.
Honestly, yeah. So let's. I mean, if you need something that's secure against physical attacks, those things exist. They're called HSM. They're called hardware security modules. And
well, HSM is useless if you can verify if you are talking to still your own HSM and not some proxy or something.
Yeah, and the way you do that is just have something that you keep on you at all times, until and unless the brain is able to do encryption internally, that problem will exist. So let's just ignore that for now.
Yeah, there are a whole bunch of problems that literally cannot be solved without brain implants.
Solving problem by ignoring them. I like it.
Demi, but
the point is you literally
I think
fix,
this stuff is most useful for servers, and when it's done there, it will trickle down to desktop. kind of free. So I guess that's how to approach this topic.
Okay, so basically, so how would I'm just going to start by, so let's have whoever, Marek, what were you going to say?
Yeah, so generally, I think some of the technologies are useful because if you consider hardware like physical attacks, then there are a lot of things you are not able to cover. But you still can, it's still some of this can help with very simple attacks like planting backdoor in your kernel or other boot files, or well, firmware is a bit more complicated because you need model-specific implant for firmware for specific hardware. It's much easier to implement it in the kernel or in IntraMFS or even file system, but that's probably encrypted. So DRTM can help you with protecting this part, and it's complicated technology, but it helps you with combating a very simple attack, which I think is worth doing. But for more complex attacks, you probably need some physical measures.
Okay, I think like we have also Daniel. Daniel, like what do you think? Like what do you think? Is there any value in the ecosystem for, like, thanks to the CC confidential computing technology, improve the home lab, or maybe DRTM can improve the home lab security, and how it would do this?
I think we're saying different things. Some people don't hear or see anything. Some see but don't hear you, and some like me see the screen from your point of view in a very recursive manner.
Yeah. This is like because I'm screen sharing. I should disable it. But Daniel, do you hear me? Daniel Smith. He was hearing me some time ago, but maybe he's not there.
Right, but maybe for the listener, would somebody like to elaborate? What's the use case if we are excluding physical attacks? What's the benefit?
Marek just went through that. The simple fact of the matter is that you cannot mitigate physical attacks with software changes.
I can't hear you, Andrew, anymore. Oh no.
You can't mitigate a whole bunch of the physical attacks with software things, and a whole bunch of the attack scenarios of physical problems have mitigations that are not software based that you might wish to do. The example given is, for example, what happens if you've got a vulnerability in your OS and someone dropped a UEFI signed rootkit or a bootkit, because those really do exist. They really live in the ecosystem. So simple signature-based checking doesn't.
And we just.
Okay, since we are back again.
Okay, do you hear me?
I guess so.
Yeah, I hear you now, and I hear Andrew this time.
Okay. Maybe this will be better. I don't know if this instance restarted or what's going on. I will try
Overloaded.
Yeah, I don't know. I can go to Amazon, look what's going on with this instance, but this is crazy. Like it never happened like that. It happened on our instance, but not on Amazon instance. But anyway, maybe Daniel, you can, if you if this works, then maybe you can say something about, like, did you heard anything about what we were talking before, or?
I was getting half conversations. I mean, the last I kind of really was following when there was the argument over, or the discussion over hardware security, and to punt on it. But then I kind of lost it at that point.
Yeah. I guess like Rich give that point that like the protection, the physical protection is still, and like we should, like, this was invented a long time ago, and this was like, okay, good comment, but the point is that confidential computing give that promise. Of course, like, I know that everyone will say this is false promise, and everyone's saying how broken it is, and I'm like, this is like I'm more caring about how we can improve homelab security, and with the assumption that we have intranet workload, with the assumption that there is physical threat to the device, because like the hope was that confidential computing brings some value for that. But if everyone agrees that confidential computing does not bring value, then how all the hyperscalers switching to that? This is crazy. This doesn't make sense.
The whole thing with confidential computing was that you put your security as armed guards on the data center. That is your physical security in the threat model for 99% of the money behind confidential compute.
Correct, and it's protecting you against the administrator, not the physical.
Yeah, the confidential computing has tried to create a trust model where the subtle way they would say it is that you didn't have to trust the hypervisor or the operator, the data center. You relied on them for the physical security standpoint, but you didn't. Their staff wouldn't be able to manipulate or control your loads running on their systems. That was the idea behind confidential computing.
So it depends which one. The old SGX was actually like theoretically secure against hardware attacks.
No.
I attempted to have a conversation about that where we were having audio problems. So yes, the old SGX did use a Merkle tree for it, but the reason SGX failed was that Merkle tree has performance problems with log height of the tree. The reason they could not extend it onto servers was the Merkle tree got too high, and it simply took too much performance to do. So they started off with something that was actually very well designed, but it just did not scale large enough to make it work on servers. What you will notice is that on Skylake, SGX existed on client and strictly only client. It didn't exist on servers. Then Ice Lake, the thing they were trying to do on Ice Lake, because when it's one single CPU, so when it's a laptop, when it's a desktop, all your security is in the same single package. The problem with servers is you've got multi-socket servers, and sorting out the crypto on that was a nightmare. So that's why Skylake server didn't have it. It was a key coordination problem. Ice Lake servers tried fixing this. So Ice Lake servers have QPI link encryption negotiation by default, after which they could then effectively share the SGX enclave secret between the two sockets, so that it didn't matter where you were scheduled on one or the other, you get it. But the thing is, at a server point of view, you wanted to go to gigabytes and gigabytes of EPC page cache, and the Merkle tree algorithm just it wasn't even diminishing returns; it was exponential performance problems by doubling the size of
exponential.
Yes, because of how x86 memory ordering works.
What are you saying? There are, with looser memory models, it wouldn't be an issue. It wouldn't be as much of an issue.
It would be less of an issue with a more relaxed model, but fundamentally, it's still a problem. You were issuing log height of the tree numbers of reads, modify, writes based on the size of the page cache.
So there are
you can swallow that performance problem when it's 4 or 5 levels high, and you can't swallow that performance problem when it's 16 to 20 levels high.
Okay, but we're still drifting. Like
this is still drifting though. So just to give my own opinion, my thought is that confidential computing, in the case where they're with current things, I think I think as far as can it help, I think it can help against very simple attacks, the kind that are very easy to carry out by unskilled attackers. But as far as non-physical attacks, I think it can help against that quite a bit.
So what would you say about TME and TSME, about the memory encryption part?
That helps against cold boot attacks, which is which is a kind of physical attack that can be prevented against, because it is trying to protect. It is talking about attacks on stuff not in use. The one physical attack you can protect against is offline decryption by people who don't have the keys.
All right, so real quick, can we split two things? Can we refer to confidential computing as an architecture that was led by a group of people, and then there's hardware capabilities that were introduced that, whether it was motivated by the architecture or not, to provide typically some kind of level of isolation on the device?
Okay.
Because when you talk about confidential computing, I think about the confidential computing consortium with their architecture, like I said, that was running with the belief that they could separate user workloads from host workloads, that the owner of the guest workloads could have control over unsealing, decrypting, and protected execution from the host system.
Yeah, I'm afraid when I made the wiki page with the title Confidential Computing, I wasn't aware of this working group. And the way I understood it, how other people use this word, is you run stuff in the cloud, but the cloud admins, they cannot snoop or manipulate any data. That being the main purpose.
Correct.
I will go further, and I will just say that another advantage is that it could have to do with regulatory requirements in certain jurisdictions, in the sense that it may not be possible to require you to tamper with your own hardware. It is, if I understand correctly, definitely not legal to require you to ship malware to end users signed by your keys. And I'm looking at, but that is probably the biggest. But I think
apparently
from
a
home perspective, I think the answer is that it's of somewhat limited. I think of somewhat limited value, in the sense that you just wind up moving the problem to your client device, except for the case where you're accessing stuff remotely. I think.
Just to butt in very quickly there, one other thing. Obviously, the thing that is said publicly is, I want to protect my workload in the cloud from the cloud admins. A larger chunk of money behind confidential compute is actually private clouds, particularly private clouds that have regulatory requirements around them. The private clouds, and by this read government private clouds, want confidential compute just to have an extra step of defense in depth in the middle, because they will take any defense in depth they can get.
Why homelabs would not like it? Why homelabs would not like this extra functional?
No, I mean, a home labber might want extra defense in depth. That's fine and valid for them to use. One of the defense in depth things, so in the case of the private cloud, you trust both the guest workload and the guest hypervisor not to be malicious to each other. And what confidential compute gets you there is if you've got an accidental memory corruption bug, then you're going to get junk. You're not leaking. You're not violating the integrity of it. So it is genuinely there, or rather, one use case of confidential of what exists in hardware for the thing we're calling confidential compute is that it also adds a layer, a defense in depth layer to accidental bugs in your software stack.
I would like to disagree with that. I think, yeah, at least as I understood the confidential computing, you do distrust your server host and as well as the hypervisor. You distrust all. And you want to use a remote attestation to prove that the software you think you are running on the server is actually running on the server. That would be like, yeah, the perfect solution, the end goal.
So I
Right.
think Andrew's
Yes.
point is that
Let me just give like Daniel a couple of words, because like we just want to have some round here, and I think Daniel got very good points and probably going somewhere, and we just not allowing him.
Yeah, so everybody's saying the same thing, right? Patrick summed it up just as I was trying to say, right? The model, the security model, the trust model was the idea is that you did not have to trust the hypervisor or the host. This is where my biggest complaint with confidential computing was, that you can't do that. It's just, and that I think that's what everybody's going around and around about. And so that's why I want to separate the idea of the technology from this security architecture, right? The memory encryption stuff is good, as Andy was saying. If you don't use that model and you are in a situation where you actually have a trusted the hypervisor that you're trusting, you are in control of the hosting environment, then you can have a different security architecture where you're using these memory encryption to provide you isolation capabilities for a defense in depth approach. All right.
Okay,
but why wouldn't it
be
possible if you have all the right ingredients? Like you have the memory encryption, maybe you need VeriFeed boot, and yeah, what else? Yeah, remote attestation. These are like one of the three main ingredients, and if they are all there, then it should be perfect in theory.
Except for what has control of when your VM gets scheduled? What has control over how much memory you get?
Yeah. This the system administrator. Of course they can remove a RAM bank or stuff like this. That's still possible. But even the amount of RAM could be covered by the remote attestation.
Right, but you can also control what devices are attached to it.
Yeah, right? Sure. This has all to be covered. Yeah.
Right. So all it ever buys you is confidentiality. It does not, and to some degree, integrity, but you don't get availability, right?
No, availability is impossible. Yeah.
Exactly. So if I'm an attacker, if I can't get to your secrets, if I can cause just as much damage by depriving you of your execution, I can do that. Right?
Yeah, sure, but I'm not sure that's like a very important threat model. Think about all of the people, all of the banks who host their stuff in the cloud. Nobody is gonna pull the plug on them forever because they don't like this bank or something like this.
I remember just a few months ago, Microsoft caused a major problem when they, or actually it was CrowdStrike, right? And crashed computers all around the world. That was kind of disruptive.
You say a few months, but that was back in January.
Fuck.
Sure, yeah, but it's not a threat you can solve on this level. Maybe you need like multi-cloud architecture, so not a single cloud can pull the plug. But I think that's a different problem to solve the availability.
I guess, I mean, we can discuss threat scenarios, but that's not even a remote threat scenario, right? I mean, any attacker can do that to you. I mean, the question is what's motivating your attacker? What are you protecting? and whether or not I mean, I would say that most businesses care about availability.
Yeah, it depends.
Most
Cryptocurrency.
businesses don't care about availability until it is taken away from them, at which point they care very, very much about it and have no recompense.
Exactly.
Yeah, I think
but yeah, we still have to get back. I just want to put everything on track. Like, we still want to discuss the improvement for the home labor, for someone who's got stuff in his own home, not for corporations. Like, we don't care about them. We care about we care about home labor and technologies that corporations deploy for seemingly improving or implementing some architecture which seemingly should fix some threats. But yeah, we have different opinions if this really happened. So my question is, like, are those technologies useful? You saying memory encryption is useful? Okay, TSME, TME is useful. What else? Is there anything else which is useful there?
So I would say, but so now if you, instead of worrying this way, so to continue from separating these two, now if we get rid of the confidential computing security model and you switch over to home lab, right, where you have people in control, you own the system, you control the system, right? And now you're worried about, instead of worrying about keeping your workloads away from your hypervisor, now you start working with, let me keep certain workloads that I don't trust that have network access away from my more critical loads. These technologies will allow you to do that. The memory encryption, which is the primary thing that's provided along with the attestation, could be used as well, will strengthen that for your home user. And you, as a provider of solutions, you could build something that takes advantage of it. Now I'll let Merrick speak now.
Yeah, so there are two parts here. One is protecting at runtime, and there we have this memory encryption, etc. But there is one more point about boot security, because if something goes wrong, if you have some DRTM or something built on top, you can recover by simply restarting the system, and you can verify if you are in the clean state. And this is, I think, also valuable, very valuable, has very much value in this use case. Yeah, and this not only about physical attacks when somebody comes and replace your disk or boot files or something from outside, but even from inside. If something goes wrong, then if you reboot, you can verify if you are still if you still own the system, right?
Yeah, I will break it down to call this verified boot and remote attestation.
Yeah, makes sense. So one thing is you can also how you verify it. There are various approaches. You can use some kind of remote attestation, when this remote can be also semi-remote attestation with some USB token or something like that. But you can also guard your protection encryption keys or have them sealed to some secret that is only available to the pristine system. There are a lot of possibilities, and I think those technologies are very much useful in this use case. I'm not sure about the usefulness of memory encryption, because it protects, adds additional layer of protection for runtime issues. It protects about cold boot attacks, which is not clear whether they are in scope or not. But otherwise, especially with different keys for different VMs, it also adds a lot of complexity, and it's also a cost, right? Some things can go wrong.
Yeah, I would also like to talk about the complexity. Do I even want the UEFI payload, or do I want CBIOS? Because CBIOS has I think 50K lines of code, but UEFI payload has 1.5 million. So is it really justified? these features with a much higher attack surface because it's much more code where something could be hidden in plain sight.
Yeah, this is a very good point. And actually, with TrendBoot, we have ongoing discussion with what to do about UEFI and runtime services. And I think the current consensus is to simply disable them because there is no way to prevent them from compromising system. So yeah, you simply disable this extra stuff you don't need after attestation. Yeah.
I guess you may have SMI transfer monitor, which kind of improves your position, and that's some additional protection you can add. But in case of UEFI, the problem between like CBIOS is, let's be honest, is terrible. Someone tried to introduce some security features to CBIOS and essentially get on mailing list feedback that this is not the place for introducing this because there was a very good comparison that you're essentially trying to create solid steel doors for the house, which is like very thick walls and really open windows and like everyone can go just around these great doors. Yeah. But TCB, the question is what is more important, TCB or fact that everyone using it and trying to validate. Of course, like in big code base, you will have a lot of issue, but you can compare that to Linux. Let's not use Linux. Let's use some small kernel just for the value of it being small. We can do this. Like we can try to do this. And we have small TCB.
Well, I would say it's not just about having the smaller TCB, but it's having a verified TCB, right? You can go grab some random small kernel, and that's not going to guarantee you that just because you have a smaller TCB that you're safe, right? Whatever you have, you need to have some degree of confidence that the code is correct.
Yeah, right. But how do we verify all of these codes? I don't know how many lines of code we are using when we use this complex kind of firmware. It's like millions of lines.
Yeah. So yes, in terms of verification, a smaller code base is going to make it easier to verify.
Okay, we slowly have to wrap up, and so I would like to at the end like those.
You became muted.
Yes, you are muted again.
Okay, right now?
Yeah, it seems to be that random people get auto-muted when someone leaves the conversation, as someone leaves the channel. Because that's what happened to you, and it's what happened to me earlier.
Okay, interesting case. But anyway, so I wanted to wrap up because in 10 minutes we have another segment. So maybe let's try to quickly summarize what are our thoughts based on this discussion on improving the security, if it is even possible. So I would start maybe with Michał because he didn't say too much, and then we can go like Marek and Daniel, Patrick. Who else didn't say something? Like Andrew, you can also like jump in. So Michał, please tell us, what do you think based on this discussion? What are the reasonable ways of improving homelabs security?
I think the most useful part is this memory encryption, but for the rest, I'm not sure. At least in the case of a home lab.
Okay, but from the perspective, like this is like enabled in firmware. What about operating system? Does operating system got any value? Like do we have any confidential computing value in operating system? What about attestation?
Sure.
What about attestation part?
Locally, I'm not sure if that will be useful.
So for SGX, it's only remotely.
So with SGX, it can be local, but for SGX right now it's tricky because it's only on servers. the SGX was removed from client CPUs. So for homelab, this has very limited usability. So only if your homelab has like a real server, then only that server will have SGX or TDX.
But it will work with local attestation?
Yeah, I think you can make use of that, although the usages are quite limited. There is a feature of local attestation there.
I have a question. Is the does the use case require internet access, or can the server be offline?
I guess it would be. I don't know, Patrick. Can you like tune in? I guess it requires because it requires.
As far as I know, it requires initial provisioning with Intel servers, and then at least for some time, I'm not sure about the details, but then you can do the attestation locally with some attestation server which was like provisioned by Intel, something like that.
Yeah, no, I'm just speaking about the specific requirement that we're talking about in this session. Like what the home lab that you're describing, do you envision the server needing services on the internet, separate from attestation just for functionality, or would everything be local and self-contained?
Yeah, that's a good question. I don't know, Patrick. Can you jump into that?
Yeah, I'm not an expert for the remote attestation, but it depends what you mean by local or remote. Yeah, if you want to use it in your home lab.
Attestation. I'm just saying for functionally, why do you have the server? What is it doing? Does whatever it's doing need anything on the internet, or is all the data local?
Yeah, I mean, which server doesn't do something on the internet? That's, I guess, rare. Even if it's just transferring data back and forth as a storage.
Okay, so can it have no internet access?
No, then you can't attest it from remote.
No, there is like you can do like a local like a remote attestation to the locally like present thing. Yeah.
Yeah, you can have a device in your local network or USB connection or some stuff like this to do the attestation. Yeah.
But would that satisfy intranet workload? Like I guess updates for the operating system is something that you're reaching out outside. But like, do you really need someone accessing from the external network from internet to you're not serving anything for the world, so that way not. But the question is if you have to go outside for something, like I guess operating system updates are something that you have to go outside, like CubesOS updates.
Yeah, in theory there is apt offline and stuff like this. You can upgrade offline, but it's complicated. I'm not sure anyone actually doing it, maybe except some companies, the extreme use cases.
I'm just asking because you use the word like intranet or private cloud, and those situations have no internet access. Intranet is not internet.
My point was about exposing services only in intranet. That's some homelabber use case. So I have my, I don't know.
Intranet is very different than air-gapped.
Yes, I'm not saying this is air-gapped. I never mentioned air-gapped here.
North Korea has a countrywide intranet.
Yeah,
I guess you can simplify this. Like one device which is external verifies another. If it's intranet or internet, it doesn't really matter. It's on a different level.
Yeah, well, but I guess it's important for the threat model.
Yeah, exactly. And because if the device can connect to the internet for any reason, it makes a big difference.
Yeah, I mean, if you connect over LAN, that's fine too. The remote attestation doesn't quote unquote know if it's internet or LAN.
Yep.
Okay, Marek, Daniel, last words, like 2 minutes for each, maybe. I don't know. Maybe we will leave something for Andrew.
I guess just kind of a closing thought. So I would say, again, anything that can increase isolation integrity in terms of attestation, you can always leverage it to increase your security posture. You can
But do you
always
see
argue.
any confidential computing helping that?
Are you talking about the technology or the architecture?
Features, not the architecture.
Yeah. So yes. So those are hardware embedded capabilities that provide either memory encryption, direct attestation measurements, or direct measurements in the case of on AMD, right? You can get a internal attestation of whatever was loaded into the encrypted VM. These things could be used. I think they would be helpful.
You're muted again.
Yeah. I just noticed someone left. But Daniel, that's a very good point. So essentially, encrypted VM is a attestation, is a something that we're using for attestation flow, correct? Or am I misunderstood?
Yeah, I mean, if you're using encrypted VMs, in theory, it's supposed to allow you to load an encrypted payload that can only be decrypted inside. So you can't really, if you're using that kind of capability, you can't really, you don't want to attest to the measured, or you don't want to attest to the encrypted payload. You would more likely want to attest to what was actually loaded into memory, and that would give that to you.
Marek?
Yeah, so I think I agree with Daniel here. So any of those features that can improve your adds a layer of security can be useful, especially if you can have attestation, so you can verify if you are still running what you think you are running. So yeah, different technologies have different complexity. So some of them may be a lot of work for not that much of benefit. But if we talk just if it's helpful, yeah, I think so.
Okay. Thank you very much for all those opinions and all this feedback. Like we essentially pointed a lot of issues in confidential computing from perspective of architecture and from perspective of implemented features, hardware features that trying to address that architecture. I guess I don't know, Andrew. Any last comments?
Just something that has been glossed over a little. Yeah, every single one of these provides new capabilities, and they're there for a reason. There was a good reason to put them in at some point in the past, enough of a reason to not do the bazillion other things that the CPU vendors would want. But it doesn't come without the complexity. The complexity on a lot of this stuff is astronomical compared to other things we're on. And something we're certainly seeing within Trench Boot is the complexity is sufficiently complicated that even the original vendors aren't necessarily getting it right. So there is potential, but it is certainly not a guarantee that if we did the software right and started using it, that it would just work.
Okay, so thank you very much for this segment. I guess we are 11 p.m. Central Europe time, so we're switching to the next talk.